Okay, so in this part of the lesson, we're going to simplify polynomials and we're going to try without tiles. So tiles will model only so many polynomials. So we have to be able to add and subtract, or we'll have to be able to simplify polynomials without them. So when simplifying polynomials, we leave the terms alone. So we don't change the variable. How can I put that? Don't change the variable or the exponent. So we keep the terms alone. However, we add and subtract, or subtract, I should say, or subtract our numerical coefficients. Okay. So when we are zeroing them out, when we were doing the lesson before and we were zeroing out a red and a yellow tile, we were actually just dealing with the numerical coefficients. So let's do a couple examples and hopefully this makes a little more sense. So here, if I have 3 x's and I have 5 x's, they're both positive. There will be nothing to zero out. I will have 8 x's. Because all I really did was I just added my numerical coefficients and I left my variables and exponents alone. Here I have negative 3y. Now if you guys have, have problems seeing the difference between a negative and subtraction, you can write all of your subtraction statements as addition statements. Okay, so we have negative 13a squared plus negative 10a squared. So since we are adding, we're not going to change the tile. We're not changing the variable. We're not changing the exponent. We're not changing that it's an a squared tile. But we are going to say, well, I have 13 negatives and I'm adding 10 more negatives. Well, that gives me negative 23. Okay, so here we have an NM, here we have an NM, and here we only have an N. So we have unlike terms here. So we can only add the coefficient of the terms that are like. So this N is not like the others, so we're just going to keep this as N. And then I have positive 16 and a minus 17. So I'm actually at negative 1 NM. Now again, remember I said on your exams, you're never going to have a plus minus. Sorry, let me rephrase, a plus negative. So really, you will see N minus, and you will never, they won't put the ones in there either. The ones will disappear as well. So N minus NM. So up here, again, we don't have like terms. Here we have a K here, and we have J's there. So we have negative 1J, and we have negative 3J. So we have negative 4J. Okay, if you're having problems with that, you can think of them as tiles. I have 1 black tile, and I have 3 more black tiles, so I have 4 black tiles. And then the 7K, they don't have any partner to go with. They're just on its own. So 7K. So here we have an a squared and a negative 6a squared. And we have negative 2a. And I'm going to put 2 lines underneath it, and just to distinguish my like terms. So I put 1 line underneath it just because those 2 are like, and these 2 because they are like. So 8a squared, I have 8 white and 6 black. Okay, so I have 2, after I zero out, I will have 2 white, assuming that my white is positive. And then I have 2 blacks and 5 blacks. Sorry, I have 2 blacks and 3 blacks, so I would have 5 blacks. Okay, so negative 5a. And once again, since these are different tiles, this is an a squared, that's a variable tile, like they're different tiles, you can't put them together. It's like saying apples and oranges. Okay, so let's see here. We have a negative q squared. We have a 7q squared. And that's it. So those tiles are the same. So I have 1 black and 7 white, assuming that we are, white's positive, black's negative. So I have 6q squared. I have an 11p. There's no more p's. So I just attached along because I can't put them together because it would be like if I could use a tile, it'd be a different shape. I have 11p squared. They have no like terms, so I just attached them along because that would be a different shape of a tile if we did have one that could represent. And negative 8q. Okay, so that's how we would simplify polynomials without using tiles. We can think of them about using tiles. We can change subtraction statements to addition statements if that will help out. And we also have to keep in mind that we can only simplify terms that are like. If they're unlike and if they don't have nothing else to go with, another like term, then you just leave them alone. So here we have Wayne was asked to write an expression equivalent to 2x minus 7 minus 4x plus 8. So he said, okay, well 2x minus 7 minus 4x plus 8. I'm going to rearrange 2x, and I'm going to put the negative 4x here, minus 7 and plus 8. So all I did was rearrange. We talked about that. Equivalent expressions are expressions. It doesn't matter what order they are in, as long as they are represented by the same picture of tiles. They are equivalent. Okay, so let's see what's happening here. So I have positive 2x and negative 4x. Okay. I can already see the error. And then I have negative 7 and positive 8. Oh, wow, there's 2 errors. That should be a negative 2x and a positive 1. So he made errors on his signs. So just be really, really careful with that. And then show the correct simplification. I already did that as we were going through it. So again, we learned that there are like terms and unlike terms, and we talked about zeroing out, just a review of grade 7. Here's a few questions here. Make sure you do that assessment focus question and hand that in to me. This is not finished early. This is if you want honors in my course. You need to be exposed to a certain level of questioning, and that question is number 22.